Okay, it looks like it was just that resistor, or those two resistors. There were 6 watts. Two of those in parallel would have been 12 watts. They were 2K. That would have been 1K. Well, I don't know what those ones are, but that's one, the two that I took out of there. So I found a 1K at 10 watts. It's not quite 12 watts, but I figured I would just dummy that in. I dug that out, soldered that in, and it actually works. And I actually found out that the voltage on AC and DC are both the same, which is good because it's never seemed to have done that. So if I key down, so I have the switch on DC, it's pushed in. So there's 4 kV, and I go on AC, and it's about 4 kV. The only thing I got to do is I got to do some insulation here. This isn't connected, so okay. You need to have this one in your hand because that's the control to actually fire the device. I don't have the high voltage lead plugged in, so I don't have to worry about that on my tip. And then the other one is over here, the auxiliary one, standalone one. But there's some arcing going on here, so I'll show you here. If I turn the voltage up, yeah, did you hear that? I'll crank up a little more. So I need to get some insulation. It's arcing right in there. See it? So I either pump some RTV in there or do something. Yeah, so based on HiPot testing, the HiPot tester. So I don't know how hot that's going to get, but we'll find out. But little sketchy, but at least I didn't totally waste my money on that damn thing. So let's see if that thing's getting hot. Nope, ice cold, but I'm not putting a load on it. I have to do the math. 20 milliamps, 4,000 volts, dropped across the 1K resistor. So there we go. See ya.